And for more NASA videos, hit subscribe.
Get your Rose ka dose.
CSU 1000 Plus. Give your best her rose.
This is the Mars rover Perseverance, the most advanced robot to land on another planet. In this video, we'll take a look at how it was built, the Atlas V launch, the journey to Mars, and the scientific instruments that allow it to study the surface. This video is sponsored by Morning Brew. On February 18, 2021, a Perseverance rover successfully touched down on Mars. It costs a total of $2.5 billion. It has many scientific instruments to help study Mars, search for signs of life, and prepare the way for future human explorers. Perseverance is, of course, not the first rover to visit Mars. Sojourner was in 1997, a very small rover, and here's a person for size comparison. Spirit and Opportunity in 2004, these were identical rovers sent just a few weeks apart from each other. Curiosity landed in 2012, and then Perseverance in 2021. Same size as Curiosity, but much more advanced technology. This is not a complete list. This just shows the most recent rover sent by NASA in the United States. For most of this video, I'll be focusing on Perseverance. NASA designs and builds the rovers in Pasadena, California at the Jet Propulsion Laboratory, or JPL for short. This took about 8 years of designing, building, and testing to get Perseverance ready to go. It was built in a clean room that's free from dust or other contaminants. It's designed to work on another planet, different atmosphere, different gravity, and most of all, no repair station. It has to be engineered so well that it can last for years on its own. On top of that, it has to be light and compact so it can fit inside of the launch vehicle. Once it was ready to go, the rover was carefully packaged up and then flown across the United States to Kennedy Space Center in Florida. This is where the launch happened, the same place that NASA has been launching rockets since the 1960s. Perseverance was installed along with several other components that went along for the journey to Mars. We'll talk about each one of these pieces later in the video. This was all put inside of the payload fairing, then taken to the rocket and then lifted up to the very top. This rocket is called an Atlas V. It's made by a company called the United Launch Alliance, or ULA for short. Let me point out that the rover was actually upside down for the launch. The best time to launch to Mars is about every 26 months. If we show this with the correct scale, you can barely even see the sun. For this animation, I'm going to show this out of scale so we can see this a little better. For the Earth to get around the sun, it takes exactly 1 year, right? No surprises there. Mars, on the other hand, takes almost 2 years to get around the sun. The best time to launch is right before Earth and Mars are lined up. This is called a launch window, and it happens about every 26 months. Perseverance was launched on July 30th, 2020. The 4 solid rocket boosters use up all their fuel first. At 1 minute 49 seconds, they are jettisoned or separated from the rocket. At 3 minutes 27 seconds, the payload fairing is jettisoned, which exposes the spacecraft. Next up, the main booster runs out of fuel. At 4 minutes 28 seconds, the main booster is separated and it will fall back to the Earth. This is called the Centaur stage. Its main engine now fires up. This is what gets us into orbit around the Earth. At 11 minutes and 30 seconds, the engines shut off. This is called the coast phase. We'll stay here for about a half hour. It's a good time to check things out and make sure that everything is still working as it should. And then we relight the engines for about 8 minutes. This is called the Earth escape burn. This is what gets us on a path towards Mars. Then the spacecraft separates. It's traveling at 41,000 kilometers per hour, and it will take about 7 months to reach Mars. Our spacecraft is made up of a few pieces. Here's the rover, all folded up inside, the descent stage, this has 8 rocket engines on it, the heat shield, which slows us down through the atmosphere and protects the rover, the back shell, which protects the rover as it descends to the surface of Mars, and this is the cruise stage, provides power, fuel tanks, and thrusters, and also keeps in communication with Earth. This whole assembly stays together during the 7-month journey to Mars. We'll need to adjust our path along the way. We do this with the thrusters on the side of the cruise stage. This is called a trajectory correction maneuver, or TCM, and there are several of them on the way to Mars.
With lounges in the sky, onboard showers, and the best in-flight entertainment, it's hardly a surprise that we were recently named the best airline in the world. And with partnerships across the globe, the 140 destinations that we fly to reach another 1,700 additional cities. So when we say we're also the largest international airline in the world, what we really mean is, if you're going there, so are we.
Lay's rupees 30 or rupees 50 pack with 25% extra chips. Extra chips?
Extra joy.
Landing on the surface of Mars is nothing short of intense. They call this EDL, or Entry Descent, when light takes just over 1 second to get there. When the Apollo astronauts were landing on the moon, NASA could communicate with them almost in real time. It would take about 2.5 seconds to receive a reply. On Mars, this is completely different. If something goes wrong during the landing, Mission Control won't hear about it for 11 minutes, and any reply would take another 11 minutes to get all the way back. By this point, it will already be over, either a safe landing or a crash. This means the computers, electronics, and the software must be smart enough to do everything on their own. EDL, Entry, Descent, and Landing. Let's follow this through step by step. About 10 minutes before entering the atmosphere, the cruise stage is detached because it's no longer needed. Small thrusters on the back shell will now be used to steer the spacecraft. Next comes atmospheric entry. The heat shield will protect the rover during this time. Once we get about 11 kilometers above the ground, then the parachute can deploy. It uses a technology called range trigger, which finds out how close we are from the landing site and then deploys the parachute at just the right moment. Next step is heat shield separation. For the first time, the Perseverance rover can now see the Martian surface down below. Now we use terrain relative navigation. The rover will be taking pictures of the ground beneath it and comparing these to maps of Mars. This will be used to safely steer the rover towards the intended landing site. Next comes back shell separation. All that's left is the descent stage and the rover. The rockets on the descent stage fire up to slow us down as we get closer to the surface. Then the rover separates but still attached by some cables. They call this the sky crane maneuver. The final part everyone is waiting for, touchdown. The cables are cut and the descent stage flies off into the distance for a crash landing far away from the rover. Now it's time to check out the rover's systems, deploy the mast, and then the robotic arm in the very front. The main purpose of the Perseverance rover is to look for signs of life. It landed in Jezero crater, which, billions of years ago, used to be filled with water. Where there is water, there is usually life, or at least signs that life existed in the past. Perseverance rover has an array of advanced scientific instruments to study the surface of Mars. If you remember from earlier, the rover is enormous. It's about the size of a car. The main body of the rover they call the Webb, Warm Electronics Box. Then you've got 6 wheels, 3 on each side, that are made of aluminum. The front and back wheels can turn, allowing the rover to spin a full 360 degrees. The suspension system allows the rover to travel over rough terrain. You never know what kind of obstacles you're going to come across on Mars. But to be more realistic, the rover would be going about this fast. It has a top speed of 0.1 kilometers per hour. The slow speed is mainly for the safety and stability of the rover. This is the remote sensing mast. This is the place where you'll find some of the cameras and sensors of the rover. It's just a little taller than the height of a human. The idea is to give us a similar view of what a person would see if they were here on Mars. This big circle up on top is called the supercam. It's basically a laser that can identify chemicals in rocks from as much as 7 meters away. This is the Mast Cam Z. These are the main cameras on the rover that can even take high-definition video. Navigation cameras are used to help the rover safely drive on the surface of Mars. Right below is the Mars Environmental Dynamics Analyzer, or MEDA. This is studying the weather and atmosphere on Mars. The rover has 2 microphones, one on the mast, and then another on the side of the rover. Then we have the HAZ-cams, which is short for Hazard Camera. There's some in the front here, but also in the back. Like the name says, these cameras help avoid hazards and obstacles while driving around on Mars. The power source for the rover is called the Radioisotope Thermoelectric Generator, or RTG for short. It's a nuclear power source. The decay of radioactive elements generates heat, which can then be turned into electricity. Some of the previous rovers used solar panels to generate power from the sunlight, but this doesn't work at night, and if too much dust gets on it, well, then it's game over. Both Curiosity and Perseverance use the RTG, which means a lot more flexibility in regards to power.
सरलाक का स्पेशल न्यूट्रीब्लेंड जिसमें है नन्हे पेट की बड़ी ग़िज़ा।
This is RIMFAX, or Radar Imager for Mars Subsurface Experiment. This uses radar waves to study the ground up to 9 meters below the surface of Mars. Then there's MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. This takes the carbon dioxide on Mars and turns it into oxygen. This kind of technology will be very important once we start sending humans to Mars. And of course, the robot arm in the very front of the rover. This has a few tools at the end with some really big NASA acronyms. So here we go. PIXL. This helps to determine what chemicals make up the rocks on a very small scale. Watson, another powerful camera to see the rocks with fine detail. And then Sherlock. This provides fine-scale imaging. At the end of the arm is the coring drill. This is capable of drilling and collecting samples that will be stored on board the rover. Then it will take these samples and place them inside of the rover. A future mission is planned to take these samples from the surface of Mars and return them to Earth so we can study them further. So how does Perseverance communicate back to Earth? The best way is to use the Mars Relay Network, which consists of several satellites in orbit around Mars. These were launched long before Perseverance got to Mars. These satellites are also used for science and to communicate with other rovers that are also on Mars. For example, one of these satellites is called the Mars Reconnaissance Orbiter. So Perseverance can send data to the satellite, which will then send it directly back home to Earth. On the surface of Earth, NASA uses massive satellite dishes to communicate with spacecraft throughout the solar system. This is part of the Deep Space Network. There are 3 main locations for these satellite dishes: Goldstone, California, Madrid, Spain, and Canberra, Australia. No matter which way the Earth is facing, it will always be able to receive signals from Mars or other distant places in our solar system. Perseverance has 3 antennas on board. The UHF antenna, or ultra-high frequency antenna, this communicates directly with satellites above, primarily used to send large amounts of information. The high-gain antenna transmits directly to and from Earth, and then the low-gain antenna, mostly used just to receive data from Earth. Of course, we can't forget about Ingenuity. This is the helicopter that was sent to Mars along with the rover. Now, where would you put a helicopter on the rover? Look closely, you'll see a little tiny black compartment right here. This is where it was stored. About 2 months after landing, the helicopter was finally deployed onto the surface. The process took about a week to complete. First, the cover is removed and we expose the helicopter. Then it's unlatched, carefully folded down, the legs come out, and dropped onto the surface. Perseverance can drive away and Ingenuity can start to absorb the sunlight on its solar panels. The helicopter has 2 rotors that rotate in opposite directions. On Earth, most helicopter blades spin at only a few hundred RPMs, or rotations per minute. For a helicopter to work on Mars, we have to spin the blades a lot faster. This is because the air is much thinner here. The first test flight of Ingenuity happened about 2 months after landing on Mars, the first helicopter to fly around on another planet, and it turned out to be a huge success. As of this video, there's been a handful of flights and Ingenuity is still operational. Perseverance paves the way for future missions where we will hopefully be able to return Martian samples back to Earth. And of course, the next major milestone, sending humans to Mars. Keeping up with the most important topics nowadays can be time-consuming. How do you stay informed without just aimlessly browsing social media sites? It can be a huge time waster. This is where Morning Brew comes in. It's a free newsletter that's delivered right to your inbox 7 days a week. You can stay up to date on business, finance, and tech in only 5 minutes. Lately, I've been able to keep up with what's happening to inflation and gas prices. I've also learned a few details about Amazon finally launching its drone delivery service. You can even keep up with Elon Musk in the details about purchasing Twitter. And you'll also be pleased to know that Morning Brew covers events about Mars rovers and other space-related events. Morning Brew is witty, relevant, and informative. This is a great way to start your morning routine. The newsletter is completely free and it takes just a few seconds to sign up. Just go to morningbrewdaily.com/JaredOwen or use the link in the description below.
Abhi Bachcha Party आओ and get your favorite Obo merchandise available in-store and online nationwide.
Just feel alive.
The Soyuz is a Russian spacecraft that can fit a crew of 3 on board. It is launched aboard a massive rocket, which is called the Soyuz rocket. In this video, I'll show you how this rocket is launched into orbit around the Earth. We'll see the launch site in Kazakhstan, launch day preparations, and then their 9-minute journey into space. At the end of this video, I'll show you how the Soyuz spacecraft safely brings the crew back home. My name's Jared. I make 3D animations to show and explain how things work. This video goes really well with my previous animation, all about how the Soyuz spacecraft works, and then how it docks to the International Space Station. Both of these videos were a lot of fun to make, and I even had some help from 2 astronauts, Chris Cassidy and Scott Kelly. So a big thanks to both of them. And of course, thanks to the sponsor for this video, which is CuriosityStream, a subscription service with thousands of documentaries for less than $20 a year. The Soyuz rocket is launched from the Baikonur Cosmodrome in Kazakhstan. On our globe, let's come over here to look at Europe and Asia. This is Russia. It's the largest country in the world. Mission control is in Moscow, Russia. The launch actually takes place right below, in the country of Kazakhstan. So why does Russia launch from a different country? When the Baikonur Cosmodrome was first built in the 1950s, these two countries were part of the Soviet Union. The launch site has been in use ever since then. The other reason has to deal with a little bit of physics. Let me explain. The best place to launch a rocket is right along the equator. Anywhere along here, the Earth is spinning at about 1,670 kilometers per hour. This means that a rocket launching to the east gets a free speed boost. You still get that speed boost when you are further away from the equator, it's just not as much. If you look at where Russia is, it's not very close to the equator. This is part of the reason why they still launch out of Kazakhstan. The rocket gets a little more of a speed boost. The Soyuz rocket is about 50 meters tall. The Soyuz spacecraft is hidden inside at the very top. This covering is called the launch shroud. This whole rocket is assembled just a few kilometers away from the launch pad. First, we start with the Soyuz spacecraft inside building 254. There are lots of tests to make sure it works correctly here on the ground. Then the Soyuz spacecraft is turned on its side and loaded into the launch shroud. Remember, this is the part of the rocket at the very top. This is all transported next door to building 112. This is where the Soyuz rocket is assembled in the horizontal position. The rocket is then transported to the launch site on a small train. This process is called the rollout, and it happens 2 or 3 days before the launch. The train moves slow enough that you could walk right next to it. It takes only a few hours to reach the launch pad. There are red protective coverings inside of each rocket engine. These will be removed shortly before the liftoff. The rocket and the train will slowly pull up right up next to the launch pad. Then the next step is to lift the Soyuz rocket up into the vertical position. 4 support trusses grab hold of the rocket to secure it in place. Then the 2 umbilical towers to supply power and fuel. And then the service towers, which rotate right up next to the side of the rocket. You can see how it has several levels to access different parts of the rocket while on the launch pad. Just for comparison, NASA in the United States builds rockets vertically and then transports them to the launch pad on a large crawler transporter. 2 different ways of doing things, but they both work. Let's talk more about the Soyuz rocket. It's powered by kerosene and liquid oxygen. Here's a view of where the tanks are inside of the rocket. It takes up most of the space. This is a 3-stage rocket. The first stage is made up of 4 side boosters and the central block. The second stage is made up of just the central block, and the third stage is the smaller block right above it. We'll see this in action in just a few minutes. Most of the rocket engines are on the bottom. The larger engines are fixed in place. They don't move at all. But the smaller ones, these are called vernier engines. They can rotate to steer the rocket. There's 2 on each side booster, and then 4 on the central block. Okay, so we have the first stage, second stage, third stage, the launch shroud with the Soyuz spacecraft inside, and at the very top is the launch escape tower. If anything goes About 5 hours before the launch, the tanks begin to fill with fuel and oxidizer. The 3 crew members will arrive at the launch pad in a bus. They will be wearing Sokol spacesuits. These protect the crew during the launch and other important parts of the mission. In their left hand, they are each holding a portable cooling unit. This will be used up until the moment they enter the Soyuz spacecraft. One last picture is usually taken here on these steps. An elevator then takes them up to the top where they can get into the Soyuz spacecraft. There is a hatch in the side of the launch shroud. This leads to the orbital module, and then down into the descent module, of course being very careful not to damage anything. They are in their seats about 2 hours before the launch. In the center seat is the commander. This will always be a Russian cosmonaut. The other 2 seats are for the flight engineers. These may also be Russian cosmonauts or an astronaut from another country.
सर्दियों का मजा बढ़ाए पाकिस्तान का डेयरी एक्सपर्ट नेस्ले मिल्क बैग।
अपनी मर्जी की प्राइस सेट करें और फैमिली के लिए बेहतरीन राइड्स चुनें। इन ड्राइव राइड्स ऐसे जैसे आप चाहें।
The instrument panel is up here. Not all of the controls can be reached by hand. The commander in the center seat will have a stick to be able to reach all of them. The crew will hang a 0G indicator that's usually a stuffed animal or a toy. This is a nice visual reminder once they are in space and the effects of gravity. Before the launch, the service structure arms will be rotated away from the rocket. 15 minutes before the launch, all personnel are evacuated from the launch pad. At 35 seconds before the launch, the first umbilical tower is released. Then at 15 seconds, the second umbilical tower is released. At the moment of liftoff, the 4 support trusses rotate away and the Soyuz begins to rise. The Soyuz launch is automated, but the crew must be ready in case anything goes wrong. About 20 seconds after liftoff, it'll start pitching over to the side. At 2 minutes after liftoff, the launch escape tower will be jettisoned because it's no longer needed. The 4 side boosters now have empty fuel tanks, which means the first rocket stage is now complete. When the side boosters fall down, this is considered the Korolev cross. You can usually still see this from the ground. The central block of the rocket continues to fire on its own. As they continue to accelerate, the crew will feel as much as 3.5 Gs, or 3.5 times as heavy as they do on Earth. The launch shroud protected the spacecraft through the atmosphere, but were high enough up that it's no longer needed. At 2.5 minutes, it falls away, exposing the Soyuz spacecraft. This is the first time that the crew will be able to see outside their windows into space. At 5-9 minutes, the third stage cuts off. This is called main engine cutoff, or MECO. Shortly after, it separates from the spacecraft. The Soyuz spacecraft is now on its own. Inside the Soyuz, the 0G indicator will begin to float, and the crew members will feel weightless for the first time. Now the antennas deploy, and also the solar panels. This generates power for the Soyuz spacecraft. They are at a height of about 240 kilometers and traveling at a speed of 27,000 kilometers per hour. Nowadays, all Soyuz spacecraft are sent to the International Space Station, or ISS. The next step is rendezvous and docking. That means the Soyuz has to catch up with and then dock to the ISS. If you want to learn more about this, you can watch my previous animation, which I mentioned at the beginning of this video. At the end of a Soyuz mission, the crew will have spent about 6 months on board the ISS. It's time for the astronauts and cosmonauts to come home. It only takes about 3.5 hours to get back to the surface on Earth. The Soyuz crew will be saying their goodbyes to those that will be staying on the ISS. Then they will enter the Soyuz spacecraft and close all of the hatches and get into their seats. Then they will release the hard dock latches and then detach from the ISS. This is called undocking. The spacecraft will slowly float away. Once they get to a safe distance, the Soyuz thrusters can be used again. The target landing site is back in Kazakhstan. Half an orbit away, on the other side of the Earth, they'll do what's called a deorbit burn. The main engine is fired for about 4 minutes and 30 seconds. Notice how the Soyuz is pointed backwards. This slows the Soyuz down so its path will now re-enter the Earth's atmosphere. This is like the Hohmann transfer that they used to reach the ISS. But this time, instead of raising the orbit, now we're lowering the orbit. About 30 minutes after the deorbit burn, the Soyuz turns 90 degrees, and all 3 modules are separated by explosive bolts. The reason they turn 90 degrees is to ensure that each module has a separate path down to Earth. That way there's no chance they'll crash into each other. The service module and the orbital module will go on to burn up in the atmosphere. In fact, for this reason, the orbital module is usually filled with trash. The descent module has a heat shield on the bottom. This will protect the crew from the fiery descent. As the atmosphere gets thicker, it will slow down the descent module. This part is called re-entry. Small thrusters are used to help steer the module through the atmosphere. The crew goes from feeling weightless in space to all of a sudden having several times the force of gravity pressing them into their seats. This can be very hard on their bodies. During this time, they have what's called a radio blackout, where the fire and heat prevent any radio signals from coming through.
नेस्ले बुनियाद आयरन प्लस जो है 3 गुना ज्यादा मौसम।
The Soyuz descent module will touch down on land. This is different from the splashdown that NASA has done here in the United States. The Soyuz is also built so that in the event of a water landing, it will still float. At a height of about 10 kilometers, it's time to eject the parachute cover. This is a series of 4 parachutes. There are 2 pilot parachutes, a drogue parachute, and then the main parachute. The drogue parachute slows the capsule down enough so that we can safely open the main parachute. There's also a backup parachute in case the main one doesn't work. The heat shield is then jettisoned from the bottom of the descent module. This exposes several soft landing thrusters, which will help cushion the moment of impact. To also help with this, the seats will rise up on shock absorbers. These will help soften the impact even more. The soft landing thrusters are fired about a meter above the ground. This is why you see all of the dust come up. It's quite a jolt when they finally touch down. The parachutes are then disconnected to avoid the wind from dragging the capsule along the ground. The astronauts and cosmonauts will need some help to get out of the descent module. The recovery crew is usually close by and ready to welcome them home. What an amazing journey to be able to fly on the Soyuz. If you enjoyed this animation, you may also enjoy learning from one of the thousands of documentaries that are available on Curiosity Stream. This is a subscription streaming service that has non-fiction titles from some of the world's best filmmakers. If you like space, there's a huge section on that. There's also nature, history. It's giving me some great ideas. Curiosity Stream is available worldwide and on almost any platform so that you can watch however you want. So go to curiositystream.com/JaredOwen or use my promo code to receive 25% off a yearly subscription. That comes out to only $125 a month. As always, thanks for watching this video. I hope you learned a lot, and I will see you next time. The SpaceX Crew Dragon is the first spacecraft from a private company to take humans into space. In this video, we're going to take a look inside and see how it works. Then we'll see the launch pad, the journey into space, and how it docks to the International Space Station. Dragon SpaceX, you are go for launch. We're about to learn about an incredible piece of engineering that has overcome significant challenges. To solve these challenges, engineers need problem-solving skills that take time to develop. This is why I'm glad to have this video sponsored by Brilliant.org. With Brilliant, you can learn math and science interactively. You can actively try things out and understand why things work the way that they do. Maybe you're a professional and want to level up your skills, or maybe you're still in grade school and want a better way to understand math. Brilliant has thousands of lessons to choose from in a variety of different areas, and you can learn anytime, anywhere. I've really enjoyed some of the math lessons because you get to see things in a way that just won't happen with a textbook. You can try everything Brilliant has to offer for free for 30 days by going to brilliant.org/JaredOwen. The first 200 people will get 20% off Brilliant's annual premium membership.
Get your Rose ka dose.
CSC 1000 Plus. Give your best her rose.
The Crew Dragon is a human-rated spacecraft. This means it's capable of carrying humans into space. It was created by a United States private company called SpaceX. The company has its headquarters in Hawthorne, California. Up until now, space exploration has been done by government agencies who have billions of dollars to spend. SpaceX is really the first private company to break through this barrier. They develop both rockets and spacecraft on their own. But of course, NASA is now one of the largest customers of SpaceX. Alright, for some background, this is the International Space Station, or ISS for short. It's been in use since the early 2000s, and it must be continuously staffed by astronauts going to and from the station. To get a ride to the ISS, astronauts could launch on either the United States Space Shuttle or the Russian Soyuz spacecraft. The Space Shuttle is no longer in operation. It was retired in 2011. After that, the Soyuz was the only way to travel to the ISS. There was no other spacecraft available to take humans into space. The year 2020 changed all of this. The Crew Dragon flew astronauts once again from American soil. The Dragon spacecraft has a few different versions. First came Dragon 1. This was a cargo spacecraft that brought supplies to and from the ISS. It had more than 20 flights bringing cargo to the station. This version of the spacecraft could not carry humans, only cargo. Then came the Dragon 2. This has two versions, the Cargo Dragon and the Crew Dragon. The Crew Dragon can carry people and cargo into space. Cargo Dragon looks very similar, but it can only hold cargo. So it doesn't need life support, aboard engines, or controls inside the vehicle. For this video, we'll be focusing on the Crew Dragon. That's the part that's most exciting to me, bringing humans into space. The Crew Dragon is split up into two parts. This is the capsule, and this is the trunk. The capsule is also known as the pressurized section. Inside, there's air to breathe, and they keep the temperature nice and comfortable for the crew. This is the nose cone. It's closed for the launch, but they will immediately open it up once they are in space. This exposes some sensors, thrusters, and the docking mechanism that will be used to attach to the ISS. The Dragon capsule has 16 Draco thrusters, 12 of them on the side, and then 4 more up towards the top. Draco thrusters are used to change the orientation of the spacecraft. They are also used to change the spacecraft's orbit, so they can reach the ISS at the beginning of a mission, and then deorbit at the end of a mission and come back to Earth. Additionally, there are 8 Super Draco engines, and these are significantly more powerful. If there is an emergency on the launch pad, all the way up until they are in orbit, the Super Draco engines can quickly get the crew to safety. On the bottom is the heat shield. This will protect the crew as they enter the Earth's atmosphere at the end of the mission. At one point, SpaceX had plans to have landing legs and extend them through the heat shield. This is so that the capsule could touch down on land. This would have been really neat to see. However, due to cost, complexity, and time schedule, SpaceX turned away from this idea and decided to do a splashdown in the water like other NASA spacecraft have done in the past. The bottom half of the spacecraft is called the trunk. There's room for cargo in here, and it helps support the spacecraft during the launch. The white half of the trunk has the radiator panels, which help remove heat from the spacecraft. The other side covered in blue is the solar panels. This generates power for the Dragon capsule. The previous version of Dragon had solar panels that would unfold once in space. This can be problematic if the panels ever fail to unfold. So it's kind of nice to have the solar panels directly on the side. Just point it towards the sun and you've got power. The trunk stays attached for the entire mission. It's only detached at the very end, about an hour before splashdown. The trunk does not have a heat shield. It will fall back to the Earth and burn up as it enters the Earth's atmosphere. To enter the capsule, astronauts use the side hatch. The Dragon capsule was designed to fit up to 7 people inside. However, NASA has chosen to use only 4 of the seats. This leaves more room to carry cargo underneath the seats. The Crew Dragon has been described as a modern spacecraft. The seats are customized to the body of each astronaut, and there's a lot of room. Compare this to the Soyuz spacecraft, which, well, see for yourself. There's not a lot of room in there. If I had the choice, I would choose the Crew Dragon. Once the astronauts are fully strapped in, these seats will be rotated. The Crew Dragon can be controlled by the 3 touchscreen displays. Up until this point, most spacecraft have had tons of physical buttons, lots of knobs, switches, and dials. SpaceX has decided to go with the sleek, futuristic panels. There are a few physical controls just in case the panels fail. Most of the flying is done autonomously, which means most of it is done by the computers on board. If all goes well, the astronauts won't need to do much. Inside the cabin are several windows to look outside. And if you need to use the bathroom in space, you can use the toilet up towards the ceiling. We don't know too many details here, but let's just say privacy is somewhat limited. Right in the center is the docking hatch. This is where the astronauts will go through to get on board the ISS. We'll talk more about this later in the video. The bottom part of the capsule is referred to as the service section. This has more electronics and fuel tanks for the spacecraft. SpaceX designs their spacecraft to be reusable. Space is hard. The harshness of space and getting back down to Earth, this usually means that a spacecraft can only be used once, or at least that's how it's usually been done. You have to build a new one each time, and this costs a lot of money. With the Crew Dragon capsule, it's designed to be reused. There are a handful of vehicles that have been built so far, and they each have a serial number and they have a name as well. As of February 2023, some of these have been flown more than once, and Endeavour has been flown 3 times. The first time a Crew Dragon has been flown with a crew on board is May of 2020. There were 2 NASA astronauts on board that successfully docked to the International Space Station. Since then, the Crew Dragon has flown more flights, not just from NASA, but there was a flight of 4 civilians called Inspiration 4, and also a flight from a private space company called Axiom Space. At the time of this video, there are more missions planned as well. Things are definitely changing in the space industry. The Crew Dragon is launched on top of a Falcon 9 rocket, which is also made by SpaceX. This rocket gets its name because of the Millennium Falcon from Star Wars. That's pretty cool if you ask me. The launch takes place at Kennedy Space Center in Florida. This is Launch Complex 39A. It's where some of the most historic launches have taken place. But now SpaceX gets to use this launch pad, and it looks just a little bit different now. NASA has always transported rockets vertically to the launch pad. This is called the rollout. SpaceX has decided to do things just a little bit differently. Right next to the launch pad is the Horizontal Integration Facility. The Falcon 9 rocket and Crew Dragon are assembled in the horizontal position. Then they are slowly moved on top of the Transporter Erector. Then it's slowly lifted up to the vertical position. This usually takes several hours. The Russian Soyuz rocket is transported horizontally. They've been doing it this way since the 1960s. So this is nothing new, it's just a bit different from the way that NASA normally does things here in the US. On the day of the launch, the astronauts get into their SpaceX spacesuits and then drive to the launch pad in a Tesla Model X. Elon Musk founded SpaceX and Tesla, so it's only fitting that astronauts ride in a Tesla on their way to the SpaceX launch. This is the fixed service structure. The astronauts ride up an elevator to get to the top. Then walk across the crew access arm. At the end is the White Room. Several technicians will be there to help the astronauts get into the capsule. This is called crew ingress. It's the word they use to describe the crew getting into the Dragon capsule. There are 4 seats. We have the commander, pilot, and then 2 mission specialists on the very ends. Once they are all strapped in, the seats recline to their laid-back position ready for the launch. The commander and pilot are now in a good position to use the 3 touch screens. They are in their seats about 2 hours before the launch. 45 minutes.
सेरेलैक का स्पेशल न्यूट्री-ब्लेंड जिसमें है नन्हे पेट की बड़ी ग़िज़ा।
5 minutes before the launch, the crew access arm is retracted. 35 minutes before the launch, the propellant begins loading into the Falcon 9 rocket. Falcon 9 is a 2-stage rocket. The first stage is powered by 9 Merlin 1D engines. That's also why they call it the Falcon 9, because there are 9 of these engines. The second stage is powered by a single Merlin vacuum engine. They call this a partially reusable rocket. The goal is to be fully reusable, but we're not there yet. The second stage is not reusable, or in other words, it's expendable. We don't have an easy way to get it back down to the ground. The first stage, however, is reusable, and in just a minute I'll show you how this works. So, our full rocket stack here, the only pieces that are reusable are the capsule and the first stage. You can sometimes tell if the first stage is being reused because it won't look quite as new. The most exciting part of every launch is the liftoff. Something you'll hear the controllers say is the word nominal. They'll say we have a nominal launch or a nominal separation. This is a very good word to hear. It means that everything is going as planned. The first stage shuts off at 2 minutes and 40 seconds. This is called MECO, or main engine cutoff. Then the first stage separates. Then the second stage fires up. This is what gets us into orbit around the Earth. While this second stage is firing, the first stage makes its way back to the ground. The first stage uses cold gas thrusters to reorient itself. This is called the flip maneuver. Grid fins also come out to help stabilize it. The first stage will come down over the ocean, so they will have a drone ship waiting at just the right spot. The entry burn helps to slow it down through the atmosphere. This only uses 3 of the Merlin engines. And just moments before touchdown, one more engine lights up for the landing burn, and then the landing legs are deployed for the final touchdown. The drone ship can make its way back to Florida, so this first stage can be reused on a future mission. The second stage is going to get the Dragon spacecraft into orbit around the Earth. This is called orbit insertion. Second stage cuts off at 8 minutes and 50 seconds. This is called SECO, or second engine cutoff. Shortly after, the second stage separates. As we talked about earlier, the second stage is not reused. It makes its way back down to the Earth and burns up in the atmosphere. Now keep in mind that a lot of these events are happening simultaneously. The Dragon spacecraft is on its own now. The nose cone opens up to expose the docking hatch, sensors, and thrusters. The crew will also be weightless for the first time. Once in orbit, it's time to catch up to the ISS. Most missions take around 24 hours for this to happen. The Draco thrusters are used several times to raise the orbit and close the distance to the station. To attach a spacecraft to the station, they do it in one of two ways. One is called berthing, and the other is called docking. First, let's talk about berthing. This is what the original Dragon spacecraft, or Dragon 1, would do. It would fly right up next to it, and the station's robotic arm would reach out and grab onto the spacecraft and help bring it in. This is called berthing. We just need a little help to join to the station. Docking is similar, but this time the spacecraft can do it all on its own without the help of a robotic arm. This is what the Crew Dragon does. It's called docking. Let's take a minute to look at the ISS again. The Dragon spacecraft will dock towards the front of the station. This is called Node 2, or the Harmony module. Attached to it is the Pressurized Mating Adapter, or PMA for short. There are 3 of them. PMA 1 is in the middle of the station, and then at the front is PMA 2 and PMA 3. The space shuttle actually was last docked here to PMA 2. This was back in 2011. Since then, they've added the International Docking Adapter, or IDA for short. This uses the newer docking mechanism that Crew Dragon is also using. So Crew Dragon is able to dock at 2 different locations. Most of the missions so far have docked to the very front of the station. In preparation for docking, Crew Dragon will extend the soft capture ring. Crew Dragon spacecraft will go through a series of waypoints, and these are points in space where they will stop and complete checks to ensure that the spacecraft is in good condition to proceed with docking. First, we have waypoint 0. This is 400 meters directly below the ISS. Next is waypoint 1. This is 220 meters directly in front of the station. They will line up along the docking axis, always pointing the capsule towards the docking port. Then they will slowly proceed to waypoint 2. This is 20 meters in front of the docking port. As it slowly moves in, you can see the Draco thrusters firing to keep it in line with the station. Once confirmed, then the spacecraft proceeds to dock, but moving only at a few centimeters per second. Once within 5 meters of the docking port, they have what's called CHOP, or crew. Next to it is the Launch Control Center. Notice how it's positioned with a good view of both launch pads. This building is called the Orbiter Processing Facility, or OPF, and actually there were 3 OPF buildings. It's where the orbiter was serviced in between missions. Over here is the Shuttle Landing Facility. This is where a mission ends for the space shuttle. But they didn't always land here. Sometimes, due to weather or other circumstances, the shuttle would land in California at Edwards Air Force Base. When this happened, we need to get the orbiter vehicle all the way back to Florida, and the shuttle can't really take off again and fly like an airplane. It wasn't built for that. So here's what happened. The orbiter vehicle was taken to the Mate-Demate device, or MDD, which would lift up the shuttle and then load it on the back of a special airplane called the Shuttle Carrier Aircraft. It was then flown across the United States to get back to Kennedy Space Center in Florida.
Crunchy crunch, Cocoa Crunch.
It was then taken to one of the OPFs. Once inside, the engineers would literally crawl all over it to fix or replace many of the shuttle components to make sure that it's safe to fly for the next shuttle mission. This process can take several months to complete. This is part of the reason why the space shuttle was so expensive. Meanwhile, work starts over here at the VAB. We start with the solid rocket boosters, which are assembled piece by piece. On the inside is the solid rocket fuel. Once ignition starts at liftoff, it cannot be turned off. Now it's time to lift the external tank into place. Inside there are 2 smaller tanks, one for liquid hydrogen and one for liquid oxygen. These tanks will remain empty until just a few hours before the launch. Now at room temperature, hydrogen and oxygen are both gases which take up an enormous amount of space. But if we put them at extremely cold temperatures, they will turn into liquids and we can put a lot more fuel inside of the tanks. The liquids from each tank will flow through pipes down to where it will connect to the orbiter. This side is for the liquid hydrogen, and this side is for the liquid oxygen. Once the orbiter was ready, it was then transferred from the OPF to the VAB. This was referred to as a rollover. The orbiter was then hooked up to a crane and then carefully lifted up, moved over to the high bay, and then mounted to the side of the external tank. The fuel and electrical connections are attached to the bottom of the orbiter. There is also another attachment point up towards the top. Once this is all ready to go, we need to move it to one of the launch pads, which are more than 5 kilometers away. This is referred to as the rollout. The weight of the entire shuttle stack is supported at the base by 8 hold-down posts, 4 on each of the SRBs. It's then secured in place by the hold-down bolts. At the moment of liftoff, these will detonate to free the shuttle. The platform it's on is called the Mobile Launch Platform. Underneath is the crawler transporter, which moves everything at just under 1.5 kilometers per hour. It takes many hours to get all the way to one of the 2 launch pads. Then it's up the ramp and slowly into position. The platform is put down on supports, and the crawler goes back down the ramp. The mobile launch platform has large holes for the rocket flames. The 3 main engine flames will go through this hole, and the flames from the 2 SRBs will go through these 2 holes. Below the pad is the flame trench. During the liftoff, the flames will be deflected to each side. The structure next to the shuttle stack has 2 main parts: the fixed service structure, which doesn't move, and the rotating service structure, which can pivot around to completely enclose the space shuttle. Sometimes the payloads were loaded here in the vertical position, and other times they were loaded before this, when the orbiter was on the ground at the OPF. The fixed service structure has a lightning mast on top, and then 3 service arms. 2 of them are vent arms, which will collect excess hydrogen and oxygen from the external tank. This is the gaseous hydrogen vent arm, with the ground umbilical carrier plate at the very end. At the top is the gaseous oxygen vent arm. Because the fuels are so cold, the beanie cap is really important to prevent ice buildup at the very top. The third arm is called the orbiter access arm. At the end of it is the white room. This is how the astronauts get on board the orbiter in preparation for a launch. The moment of liftoff, many things happen simultaneously. The gaseous hydrogen vent arm is retracted from the external tank. The 2 connections at the tail service mast will retract. The 8 hold-down bolts will detonate, which frees the shuttle, and then both SRBs ignite. For their journey into space, the shuttle is mostly flown by the autopilot. Of course, the astronauts can still take over if they need to. Shortly after clearing the tower, they do what's called the roll program, to get the shuttle so that it's heads down for most of the ascent into space. This reduces the aerodynamic stress on the wings. It will also allow the astronauts to see the curve of the Earth as they ascend into space. Now, as we keep gaining more and more speed, the air in the atmosphere will create pressure on the front of the spacecraft. Then as we get higher, the air starts to thin out. They use the term max Q to refer to the time when the aerodynamic pressure will be at its highest. During max Q, the main engines will be throttled down, so we don't accelerate too quickly, but then shortly after, we can throttle them back up again. A little more than 2 minutes after liftoff, the 2 SRBs have done their job. They are detached, and then small rocket motors on the bottom and on the top fire on each booster to ensure that they are separated from the vehicle. The SRBs fall back down to the Earth where they will parachute in for a soft landing in the ocean. They will be recovered by boat and then refurbished for a future shuttle mission. Now the three main engines are on their own. As we get higher, more and more fuel will be used up from the external tank. This means that the shuttle will keep getting lighter. We have to keep throttling down the engines or we'll accelerate too quickly. The maximum amount of acceleration we want the astronauts to feel is 3 Gs, or 3 times the force of gravity pushing them into their seats. At about 8 minutes and 30 seconds, we have main engine cutoff, or MECO. This must happen before the tanks run dry so that the engines aren't damaged. The external tank is now detached. We're not in orbit yet, so the tank will head back down to Earth and burn up in the atmosphere. The 2 doors on the bottom side of the shuttle will close now that the external tank is gone. If they didn't close, we would have gaps in the heat shield at the end of a mission, which would not be so good. At this point, the orbiter vehicle is on the same path as the external tank. We're not quite going fast enough to stay in orbit around the Earth. Remember that the external tank had the fuel This is the Vehicle Assembly Building. NASA has used it to construct massive rockets before they lift off from the launch pad. In this video, we'll see inside the building and how it's been used for more than half a century. This video is sponsored by Brilliant. In the 1960s, NASA was headed to the moon. The launch vehicle for this was the giant Saturn V rocket, with the Apollo spacecraft at the top. They needed a place to assemble the pieces of the rocket, and the launch pad wasn't set up for this. This is why they built the Vehicle Assembly Building, often just called the VAB. This building is still in use today. It's a controlled environment that protects from the outside weather. It keeps the rocket safe until it is moved to one of the launch pads, usually just a few weeks before the launch. The VAB has been mainly used to assemble 3 rockets, the Saturn V, which was used by the Apollo program, the Space Shuttle for the Space Shuttle program, and the Space Launch System, or SLS, which is currently being used for the Artemis program, which will return astronauts to the surface of the moon. Construction of the VAB started in 1963, and it took 3 years to build. The building cost $117 million US. That's more than $1 billion US in today's money. Over the years, they expanded the facility around the building and also added the NASA logo, sometimes called the meatball logo, and a giant American flag on the side. The VAB is 160 meters tall. For a good size comparison, here's the Statue of Liberty and the Eiffel Tower. There are some open areas inside the building that go all the way to the roof. Because of this, some people consider it to be the world's largest one-story building. But after looking inside, that definition might be a bit of a stretch. There's a lot of different platforms in here. The VAB is located in Florida at Kennedy Space Center. The VAB is here, and on the other side is Launch Complex 39A and 39B, more than 5 kilometers away from the VAB. The large distance is mainly for safety. This path is called the Crawlerway. It's a 40-meter wide double pathway road. When the rockets are ready, they are transported from the VAB all the way to one of these 2 launch pads. They use some massive machinery to get this done. We'll talk more about this later in the video. These enormous rockets are built in quite a few different pieces. These rocket pieces have been built in several locations across the United States. Then they are shipped to Kennedy Space Center in Florida. Some of the pieces arrive by barge on the water at this turning basin. And other pieces can be flown by airplane and land on this runway, which was built for the shuttle program. Another way they can arrive is by train. Then the pieces of the rocket are brought over to the VAB. This smaller building next to the VAB is the Launch Control Center, which is facing both of the launch pads. Let's take a look inside of this gigantic building. This area is for the low bays. They can work on parts that aren't quite as big. The low bays were mainly used during the Apollo program in the 60s and 70s. And the tall section of the building is for the high bays. There are 4 high bays, numbered 1, 2, 3, and 4. These are the large open spaces that are big enough to fit a rocket. The foundation for the VAB extends beyond the north side of the building. There is space to build 2 more additional high bays, and if needed, they can even extend the roof to allow for larger rockets. However, as of the year 2024, there are no current plans to do this. On the sides of each high bay, they call these towers. So this is Tower A, Tower B, and then C, D, E, and F. They go all the way to the roof. Right down the center is the transfer aisle, which runs the entire length of the building. On each side are retractable doors, large enough to fit the massive parts of the spacecraft and rockets. Despite the size of the doors, they are not the largest openings to the building. Each high bay has 4 door panels that move left and right, and then 7 door panels that move up and down. It takes about 45 minutes to completely open the doors. The main part of the building has no air conditioning, but once these doors are opened, it does provide a draft which cools things off. There are bridges and catwalks so that workers can get in between the different parts of the building, and plenty of elevator shafts to allow workers to get to the different levels. Inside the building, there are several yellow cranes used to lift the massive pieces of the rocket. There is one crane that goes along the transfer aisle. It can carry up to 159 metric tons. And then we have 4 more cranes that service the high bays. Originally, there were only 2 high bay cranes, but now there are 4 of them. These 2 cranes service high bays 1 and 2, and these 2 cranes service high bays 3 and 4. The strongest cranes can lift as much as 295 metric tons. The operator for the crane goes inside of the cab here. I hope they're not afraid of heights. We'll see these cranes in action a little bit later. For the rest of the video, I'd like to show how the building was used for each space program. First, we'll start with the Saturn V, back when the VAB was a brand new building. The high bays used most often were High Bay 1 and High Bay 3. This is because they are facing towards the launch pad. It makes things a little bit easier. Inside of each high bay, they had several pedestals. Resting on top of this is the mobile launcher and the launch umbilical tower. The stages of the Saturn V rocket are brought into the transfer aisle. This is the first stage of the Saturn V. Initially, 2 of the cranes are used to lift it. The transfer aisle crane attaches to the lower end, and the high bay crane will attach to the upper end. Both cranes work together to lift and rotate the rocket stage. Now just the high bay crane is used to lift it the rest of the way. This all happens very slowly. The first stage weighs about 132 metric tons. The crane operator can't afford to make any mistakes here. They bring it over into the high bay and gently set it down on the mobile launch platform. On the sides of the high bay are retractable multi-story work platforms. There are 5 pairs of these. They are literally as big as a house. They are specifically designed to fit around the Saturn V. Once a piece of the rocket is in place, the platforms can move into position. This allows workers to access different parts of the rocket. Next, the crane lifts up the second stage of the Saturn V. More platforms can now be moved in place. Now the third stage. Right above the third stage is where they put the instrument unit. This is like the brains of the rocket, controlling it all the way through the launch. The very top part includes the command and service module and the lunar module, which is the part that actually lands on the moon. This whole section is lifted up as well and gently placed at the very top of the rocket. During the peak of the Apollo program, 3 of the high bays were used at the same time to assemble the Saturn V rockets. Once a rocket is ready to go, the work platforms are retracted, and the high bay doors are opened. This is called the crawler transporter. This is what moves the rockets all the way to the launch pad. NASA built 2 of these enormous machines. It slowly moves underneath the mobile launch platform and then lifts it up. Now the rocket can begin its journey to the launch pad. This is called the rollout. The crawler transporter only goes a little over 1 kilometer per hour. This means it will take several hours to get to the launch pad. All that work, and we're finally ready to launch a mission to the moon. After the Apollo program, NASA started making plans to support a reusable spaceplane, the Space Shuttle. There were 135 shuttle missions over a period of about 30 years. The shuttle had missions in low Earth orbit. It was also used to construct the International Space Station. To save money, they tried to reuse what they could in the VAB, but there were some specific changes that were needed to accommodate the shuttle. There's quite a bit of height difference between the Saturn V and the Space Shuttle. This means the platforms in the high bays couldn't be used anymore. Some of these platforms were modified and then relocated specifically for the shuttle program. There were 4 pairs of these platforms. High bays 1 and 3 were mainly used to assemble the space shuttle. High bays 2 and 4 were used to process and store the external tank for the shuttle. They were stored in the checkout cells on the sides of the high bays. High Bay 2 was also used as a safe haven in case of hurricanes. And High Bay 4 was also used to sometimes store an orbiter while it waited for the next mission. The north entrance to the transfer aisle needed to be widened by 12 meters to allow the orbiter to enter. A slot right here allowed for the passage of the vertical stabilizer. The launch umbilical towers were permanently moved over to the launch pads. During the shuttle program, they called it the fixed service structure. The Saturn V mobile launcher was repurposed for the space shuttle and renamed the Mobile Launch Platform. The first part of the shuttle to be assembled is the Solid Rocket Boosters, or SRBs. They are built in several different pieces with their solid fuel already inside of them. One by one, they are lifted up by the crane, moved over to the high bay, and assembled on top of the mobile launch platform. The work platforms are moved into position around the SRBs. Next comes the external tank. This was carefully placed in between the SRBs. When it's time, they'll get ready to attach the final piece, which is the orbiter.
Starship ενώ και το πρώτο και το δεύτερο στάδιο. Starship ενώ και το πρώτο και το δεύτερο στάδιο μαζί. Ήταν πρώτη φορά που το είδαμε αυτό τον Απρίλιο, τον περασμένο Απρίλιο. Ιδανικά θα θέλαμε να έχουμε δει και την αποσύνδεση. Εξάλλου η πλήρης περιγραφή της αποστολής είναι ότι θα πρέπει το δεύτερο στάδιο, το ανώτερο στάδιο που βλέπετε, το διαστημόπλοιο στην ουσία, να καταφέρει να φτάσει σχεδόν σε τροχιακή ταχύτητα, το οποίο σημαίνει κοντά στις 28.000 χιλιόμετρα ανά ώρα, χοντρικά. Δεν έγινε καν αποσύνδεση όπως σας είπα προηγουμένως, επομένως ως προς αυτό απέτυχε. Πέτυχε η εκτόξευση. Δεν πέτυχε όμως χωρίς προβλήματα, διότι έγινε τεράστια ζημιά στην εξέδρα, στην πλατφόρμα της εκτόξευσης. Είχαν πεταχτεί τσιμέντα παντού σε όλη την περιοχή τριγύρω. Μάλιστα είχε καταστραφεί και ένα αυτοκίνητο από όσο θυμάμαι. Σκόνη σε όλη την περιοχή. Και υποτίθεται η SpaceX έχει πάρει πάρα πολλά μέτρα για να καταφέρει να διορθώσει όλα αυτά τα προβλήματα, όλα αυτά που δεν πήγαν καλά στην προηγούμενη αποστολή. Έχει κάνει, λέει, τουλάχιστον 63 αλλαγές προκειμένου να ευθυγραμμιστεί με τις περιβαλλοντικές ανάγκες για να μην έχουμε πάλι τσιμέντο παντού, σκόνη από τσιμέντο παντού. Και έχει κάνει πάρα πολλές βελτιώσεις και στα ίδια τα σκάφη, και στον πύραυλο αλλά και στο διαστημόπλοιο που βρίσκεται πάνω. Τώρα, για όσους δεν γνωρίζουν καθόλου τι είναι το Starship και πρώτη φορά ακούνε αυτή τη φράση, να πω ότι είναι ο μεγαλύτερος πύραυλος που έχει κατασκευαστεί ποτέ στην ιστορία της ανθρωπότητας. Τον έχει κατασκευάσει η SpaceX. Αποτελείται από 2 στάδια. Το μεγαλύτερο μέρος, αυτό που βλέπατε προηγουμένως στην προηγούμενη εικόνα, είναι Super Heavy Booster, ο προωθητικός πύραυλος Super Heavy. Και το πάνω μέρος, το οποίο το είδατε τώρα και σε μια εικόνα που έδειχνε τον Άρη από πίσω, είναι το Starship ή απλώς